Hello students, welcome to e-learning. We are going to continue with the same SFD and BMD calculations. First and foremost thing, today we are going to take problem of cantilever beam with a uniformly distributed load. A cantilever beam of length 2.5 meters carries a UDL of 2 kN per meter for a length of 2 meter from the free end and point load at free end of 2 kN. Draw SFD and BMD for the beam. Now here the question itself you can understand first. A cantilever beam fixed at one end and free at other. Total span is of 2.5 meters. UDL is uniformly distributed load is spanning for 2 meters from free end and point load of 2 kN acting at free end. Now shear force calculation, first and foremost. Shear force calculation, shear force at B is nothing but 2 kN because beyond B there is no load, and exactly on the same point B, point load is acting of 2 kN and itself will be the shear force. Shear force till point C. Now shear force at C can be taken as 2 kN plus 2 kN into 2 meters, because 2 kN per meter UDL is going to act on 2 meter span. So it will be totally 6 kN. So shear force at C is 6 kN. Shear force at A is also 6 kN because there is no load acting in between A and C. So the loads which are taken in the calculation for shear force at C, the same will be taken for A. So it will be shear force at A is equal to 6 kN. Now bending moment calculation. Moment at B is equal to 0 kN because moment is force into perpendicular distance. So in cantilever beam, free end will be having zero bending moment. So directly you can write it as 0. Shear force at C, bending moment at C we are talking about. Bending moment at C. So force into perpendicular distance. First and foremost thing, point load we will take. So point load 2 into its perpendicular distance 2 meters. So it is nothing but minus 2 into 2, which is written here. Minus 2 into 2. And it is going to have clockwise moment. So we have taken minus sign there. So minus 2 into 2. Now we will consider UDL, that is W2 into L by 2. Then 2 into 2 meters into that UDL is acting at the center of 2 meter span, that is 1 meter. So 2 into 2. So totally it will be minus 8 kN meter. So bending moment at A will be minus W1 into L, that is 2 kN. Point load they have taken, point load into 2.5 meters. So here it will be minus 2 force into perpendicular distance till A. So this is perpendicular distance here. So 2 into 2.5 minus 2 into 2, which is acting here at the center of the span, and then from there till A it will be 2 by 2 plus 0.5 meters, because this span between A and C is 0.5, so it will be 2 by 2 into plus 0.5 meters. So here you can observe this is minus 2 into 2 into 2 by 2 plus 0.5 is nothing but moment calculation of UDL till A point. So next we will continue with how to draw shear force and bending moment diagram. Shear force at B is 2 kilonewton. Project all the points below. Project all the points below of the loads. Then mark B as 2 kilonewton here. Shear force at C is 6 kilonewton, and shear force at A is also 6 kilonewton. So you can just raise the point from B to C. It is UDL, so it is raising, shear force is raising, and then there is no load in between A and C, so it will go constant till 6 kilonewton. And this is the shear force diagram for the given cantilever beam with UDL and point load. Now we will mark bending moment. So as the moment values are negative, so we are taking the reference line. Above we are going to mark positive and below we are going to mark negative. So at B it is 0, at C it is minus 8, and at A it is minus 11. So it will be parabolic curve. Then in between A and C there is no loading, so it will be a straight inclined line. So this is how the bending moment diagram looks. Okay, so after finishing this, we are going to again continue with the next problem in the next video. Hope you have understood all the steps. If any doubt, please comment and you can question the doubt. Thank you. For further notifications and upcoming videos, subscribe the channel. Diploma in Civil Engineering Pratik, and please like, share and comment. Thank you.